All right. Looks like we got the recording going, so we'll go ahead and get started here today. So welcome everyone. Today we're going to be talking about modernizing legacy systems with GitHub Actions. So kind of the goal of this presentation is to be kind of an overview of some modern application principles, and then we're going to dive into more of the actual GitHub Actions, what you can do with them, how the platform can be used to benefit your CI/CD process, and some cool things that you can do. Kind of the goal is to really, give an introduction for those that may be new, and then also provide some tidbits for some of those people who may be more advanced in the subject. So we'll go ahead and get started with some introductions here. So my name is Sean Lawton. I am a software engineer here at Concurrency. I've been here for about 2 years now. I've been in software development for about 5.5 years. I work on the modern applications team where we deal with a pretty wide array of clients and projects, from smaller business applications to custom SaaS solutions and other enterprise applications. And then if you see on the slide there, I do have my LinkedIn URL there, so feel free to connect with me, shoot me a message if you have any questions. I'm happy to answer them. And then also you can just post any questions you have in the chat, and we'll go ahead and answer those towards the end or during the webinar. So Nick, I'll let you introduce
Hi, yep.
yourself.
How's it going, everyone? My name is Nick Woods. I'm a senior software engineer here, and I've been in the software industry for 6 years. So I'll be mostly handling the tech side, so it's mostly Sean's show. But again, I'm here to answer any questions. You can connect with me on LinkedIn, and I'll hand it back over to Sean.
All right, great. Thank you, Nick. So for today's agenda, we're going to be covering a few topics. The first topic we're going to be discussing is more of just some of the common architectures that we see in the applications that we build custom, and then some of the ones that we kind of maintain. And then the next item we're going to cover is containerization with Docker and other tools. We're going to cover infrastructure with Azure Bicep, which is a cool kind of language that you can use to provision resources. That is kind of an abstraction on top of Azure JSON ARM templates. Makes it a lot easier, so it's pretty cool. And then finally, we're going to discuss DevOps and the continuous integration, continuous deployment process that can be enhanced with GitHub Actions platform. And we're going to do kind of a deep dive into GitHub Actions. We're going to discuss the basics, and then towards the end, we're going to go over a more advanced example that kind of wraps everything together all in one. All right, so some of the common architectures that we see. You can see on the right side there, there's about 6 of them listed in the diagram. Most of the ones that we work with on a day-to-day basis are monolithic architectures, and then also microservices and clean architecture. So monolithic architecture is more of a single-tiered software architecture where all the components are kind of unified. So like your interfaces, your business logic, your data layers, your infrastructure layers are all united in one. Generally, your services are all going to be calling the same database. You're going to be deploying that entire project as one unit. And some of the advantages of a monolith architecture is it's easier to maintain, and some of the architects that we work with will agree with me there. But also, it can be a little bit more difficult as your project gets larger and larger. It can be more difficult to maintain and to scale. And that's kind of where the microservices come in and they shine, right? So I think within the last like maybe 10 or 15 years, microservices have become like a bigger thing as cloud adoption has came through. And you can kind of think of microservices as individual units that are kind of self-contained, right? So if you look at the diagram on the right, the second on the right side, you can see that there are 4 services inside of that architecture, and each one have their own database, and you can kind of think of them as like their own contained unit. Each of them can be deployed independently, so you don't have to, if you make a change to one service, you don't have to worry about, redeploying the entire project. You can just deploy that specific service. And like I said earlier, the kind of main benefit to microservices is it provides a lot better scalability as your project grows larger and larger. If you have like distributed teams working on specific tasks or specific services, it makes it easier in that regard. But it's also does not come without its faults, right? So it's more difficult to maintain. If you have a smaller team, and honestly, it really just depends on your use case. For the most part, you're probably not going to need to use microservices, but if your use case requires like high throughput or large services that need constant updating, that then the microservices architecture can really give you some benefits there. And the last one that we're going to talk about is clean architecture, or layered, and some people call it the onion architecture. We've been working with this. I have been for the past 2 years on a couple projects. I find it really interesting. It's not so much an architecture as it is kind of a software development pattern that you can use inside microservices and also monolith. So if you want to go to the next slide, you can kind of visualize it here. So this is kind of the visual diagram of what clean architecture intends to um, capture here. So if you look at the red circles, we've got the domain layer and the application or the business use case layer. So that's called the core of clean architecture, right? So kind of the goal of this whole pattern is that the core can remain the same and the outer layers can be interchanged with different, if you have different databases or web interfaces, things like that, or presentation layers, you can change those without affecting the inner core of the architecture. So the domain layer is mainly made up of, your domain models, your enumerations, your events, your exceptions, things like that, that aren't really going to change, and if they do, it's not going to affect or it's going to be contained inside that core layer, right? So the application layer, the one right around the domain layer, is going to have a project reference, at least in .NET, it's going to have a project reference on the domain layer, and it's able to, use those domain models or those enumerations, et cetera, inside of that application layer. And that's where your business logic is going to lie, and and that's where the outer layers can call in. So for example, if you have, think of like a web API, right? If you have controllers in that API, those controllers can call the business logic inside of the core, and you can kind of interchange it. You don't have to worry about changing the outer layers and then that having an effect on the core of the application, as that's all kind of self-contained. Now, clean architecture is language agnostic. I think it's definitely more popular in the .NET space, and it's also very highly testable. And it's where it really shines is when you have larger projects where, as the project grows, you know exactly where things are going to be, you know exactly how things should be laid out. Obviously, that kind of comes with the added complexity on top, so it may be more difficult to pick up, but it's definitely something great to know, and it's helped out in a lot of use cases that we've had, especially on our modern apps team. So the next thing that we're going to discuss here is application containerization. Now, containerization is another really cool kind of paradigm in software development where you can think of it like shipping containers on like a dock or a harbor, where you have these containers that can go on container ships and can be shipped off anywhere. You don't have to worry about what's inside the container. You know that the container can just go on any platform and go out to where it needs to go. So if you think about that in software terms, container is basically an encapsulated kind of mini computer that only has the necessary things that it needs to build itself. It can run on any OS, it can run on any type of platform, whether that be physical, virtual, or cloud. And it really just helps to enhance the development pipeline from the developer to the actual deployment. It's super easy to use, and Docker makes it really great.
Just interjecting real quick, yeah. So it's kind of
Yeah.
coming back to the legacy, application modernization. This is like a really
Hmm.
good strategy for, say, you have like an old monolithic applications running on a on-premises server. You want to move that to the cloud. This kind of helps you, you put it inside of a container that kind of pretends that kind of sets up the same environment of where it was running previously, and then you can just lift and shift that thing straight to the cloud, and kind of work, and then you can kind of modernize it incrementally later, and that kind of gets you off the ground.
Exactly. Yep, that's a great point. And there are also some services out there that provide scalability with orchestration, like Kubernetes, that everyone knows and loves. So yeah, so the next thing we're going to talk about here is infrastructure, specifically with Azure Bicep. Some of you may be familiar with Terraform, which is more platform agnostic, but we're going to be talking specifically about Azure Bicep here, which is kind of an abstraction layer on top of JSON ARM templates. It makes defining and deploying resources to Azure much more modular and much easier to manage. And it doesn't require the same verbosity that JSON ARM templates require. So basically what happens is you define your resources, and you can also parameterize it inside of the Azure Bicep modules or the Bicep files, and that gets transpiled into JSON ARM templates, which goes to the resource manager, Azure Resource Manager, and ultimately gets deployed to Azure. And later in this webinar, we're going to kind of see how we can do that with how we can deploy our Azure Bicep infrastructure with GitHub Actions, all inside of the CI/CD process. And it makes it really easy. So if you have changes that you need to make to your Bicep files, you don't have to worry about going out and manually redeploying infrastructure for all of your different environments that you have. You can define environments inside of the Bicep modules, and it just makes it much easier to manage and much easier to maintain when you may be passing your project on to other folks. It makes it a lot easier in that regard.
Definitely massively increases replicate, being able to replicate what you did.
Yep.
So in terms of setting up your environment.
And that kind of leads us into the whole CI/CD process, or continuous integration and continuous deployment. So kind of the goal of CI/CD is to reduce manual intervention, right? So the idea is to automate steps from building, testing, all the way to deployment. And one of the best tools to do that is to use the GitHub Actions platform, right? So if you look at the diagram below, we've got every step from developer to, committing via Visual Studio Code to your app repository that may lie inside of GitHub. And GitHub Actions kind of provides that bridge or that gap reduction to deploying your code to wherever it may be. And in our case, we're going to kind of take a look at mostly Azure, but this works for any type of platform, physical or cloud-based. And kind of the whole goal of CI/CD is, like I said, to reduce manual intervention, to reduce human error, and also it makes it a lot easier for teams who may be working on the same project asynchronously to be able to commit to the repository and not have to worry about messing up any kind of branch. You definitely would have like some guardrails and some branch protections inside of your repository and in the CI/CD process itself. And this kind of goes along with the entire theme here of modernization, and GitHub Actions platform provides that modernization for us.
You don't have to reach out to a ops team every time you want to deploy something. It's
Yes,
yeah.
exactly. So CI/CD with GitHub Actions. Why spend 5 minutes doing something manually when you can spend 5 days automating it? No, but honestly, GitHub Actions is awesome. It's a great platform. It really helps increase your productivity. And so we're going to do a pretty deep dive here into it. We're going to go over the basic steps, the basic primitives, and then we're going to get into a more advanced example that kind of wraps everything that we've discussed together at the end. So the basics of GitHub Actions. I think before we get to the basics, it's important to understand that GitHub Actions is a platform and there are actions inside of that platform that help us do things in our CI/CD process. So we've got 5 different primitives. We've got events, runners, jobs, actions, and workflows. And if you look at the right diagram, it kind of gives you almost like a waterfall view of the process that GitHub Actions uses to benefit our entire CI/CD pipeline. So um, the first primitive that we're going to look at is going to be workflows. If you want to go to the next slide here, thank you. Workflows. So you can think of workflows almost as their own programs. It's just a YAML file, right? So it's YAML syntax. Now this YAML file is going to be placed directly inside of the .github/workflows directory. And that directory is going to be committed to your repo. It's also going to be automatically read by GitHub, and it's going to be checked, based on certain triggers or certain events, whether those workflows should run in any given scenario. You can also define workflows within your workflows. So we have kind of a cool example on the right side here where we have a reusable workflow example. Now, this workflow will only run when it is called upon. And you can see below where it says on workflow call, there's 2 different tags below that with inputs and secrets. And those are kind of templated for when you actually do call those workflows, you can pass it things. So that's kind of something that you can do almost similar to developing. You wouldn't need to redefine that entire workflow inside of a different workflow. You can just use it, and you don't have to worry about, duplicating, right? Don't repeat yourself dry. That's one of the main principles of development, and that's kind of the entire idea behind reusable workflows here. So the next primitive that we're going to talk about is events. And on the previous slide, the event that workflow ran on was the workflow call, right? So right under that on tag. Now, an event is just a trigger, right? It's a trigger that runs a workflow in a specific specific scenario. So there's a bunch of different triggers that can run a workflow. Some of the common ones are like pushing to the repo, pulling from the repo, pull requests, timers, and then I did put a link out there if you want to click into that. There's a bunch of other um, different triggers that we can use um, to trigger our or events that we can use to trigger our workflow, in any given scenario we may need. So it's a really helpful tool here. You can have conditionals, you can have dependencies, and there's tons of documentation that you can look at that gives you a better idea of what you can do with the events, right? And then the next primitive that we're going to look at are runners. So runners are basically just machines that execute jobs, right? So there's two types of runners. There's GitHub hosted runners, and then there's self-hosted runners. So GitHub hosted runners, what it's doing under the hood is it's literally provisioning a virtual machine, and it's running that specific job, and then that virtual machine is being decommissioned all inside of the GitHub um, host. So if you look to the right, we've got two GitHub hosted runners. One of them runs on Ubuntu latest, and then the other one is just runs on Windows latest. And it makes it super easy. You don't have to go through all this manual work of defining, what type of virtual machine you need and all that crap. You can just define it all in the job, and the job will run, and then you don't have to worry about any of that. There's another option that you can use to self-host the runner, and this may ultimately save you cost if you are using a lot of compute, but you do have to maintain your own hardware and software. You can use Docker containers, and that's just kind of another option that GitHub lets you use, just a custom self-hosted runner. So the next primitive that we're going to look at are jobs, right? So in our workflows, we have specific jobs that are run. By default, all the jobs are run in parallel, but you can define specific jobs to run based on specific dependencies or conditionals, right? So each job generally requires a runner, and each job may have multiple steps. So you may have a build job or a deploy job, and that build job may follow, a bunch of different steps. And the deploy job might not, you're not going to want to run that deploy job right away. You're going to want to wait for the build job to finish, and you're going to want it to succeed before you would run that deployment job. So if we look at the example on the right, we've got three jobs here: job 1, job 2, and job 3. Job 1 does nothing. Job 2 needs job 1 to complete before it runs, and then job 3 needs job 1 and 2 to complete before it runs. And then it's got kind of an example of just a conditional where you can do tons of different things, based on outputs from the previous jobs, or other things that you may want to use inside of your workflow. And then finally, we're going to look at actual actions. And I know it may be a little bit confusing with the GitHub Actions platform and then actions inside of the GitHub Actions platform. So actions are, you can think about are like custom, almost applications that run inside of your workflow within the Actions platform. There, you can go to the GitHub Marketplace to find any kind of action that may suit your need. So for example, if you want to build a Node.js project or a .NET project, you're going to want to use the setup node action or the setup.NET action. And you can find all of these in the GitHub Marketplace, or you can write your own custom actions for certain things. And that's also kind of a really cool feature that you can leverage if you need to. So that kind of covers the 5 basic components that make up the GitHub Actions platform. So now we're going to kind of look at a simple workflow that we have here. Now this is a very simple workflow. All it's doing is it's running, it's triggered on a push to the main branch. You can see at the top right under the name. That is the event that triggers the GitHub action to run, or the GitHub workflow to run. And then there are 2 jobs, the build job and the deploy job. Each job is going to be running on the GitHub hosted Ubuntu latest runner. And there are some steps that are taken inside of the jobs, right? So the first job, it's using the checkout action, check out the repository code. It's using the setup node action, like I mentioned earlier, to set up node with a specific version of, node 14. It's installing dependencies with npm installed, and then it's running the tests with npm test. So you can kind of see how the actions inside of this job work. Instead of having to define all of the steps needed to, go out and get the node executable and install it, you can just use um, the actions, set up node. It's super easy and makes it much easier to read, and it really helps speed things up. Now, if we look at the deploy job, you can see that it's got this needs build dependency. So this is going to wait for the build job to complete. It's going to run whether it completes successfully or if it fails. And then there is some additional conditional logic at the bottom. So if you can see, there's a run with a pipe, and then it says if needs.build result equals success, then you're going to probably want to deploy that. If it doesn't succeed, you may want to do a whole host of other things, like you may want to send out a notification to someone, you may want to generate a report or something of that matter. So it's kind of just a cool thing that you can do. You can define your conditionals inside of there, and then also define when specific jobs are run. So that's a pretty simple example here. Now we're going to kind of get into some more advanced things. So the next thing we're going to talk about are secrets and environment variables inside of GitHub Actions. So in GitHub Actions, you can define your repository secrets, and then you can also define environment variables and organizational secrets. So your environment variables obviously are going to be different between your development, your staging, your production, your UAT environments. And you can maintain these easily through the GitHub web application, or you can use the GitHub command line interface. And you can also use repository secrets that may be common between all 3 environments. So if we look on the right, we've got a pretty simple workflow here. It's just called testing secrets, and it runs on a pull request. And then it's got one job. It's got the build job that runs on the Ubuntu latest GitHub hosted runner. It's dumping the GitHub context. And then if you look towards the bottom, we've got the GitHub token that is grabbed from the secrets that are stored inside of our repository secrets section of our GitHub repository. So it just makes it super easy to grab those secrets, and you don't have to worry about exposing any kind of sensitive information. All right, so the next thing we're going to talk about here are some really cool use cases that you can use GitHub Actions for. First one is semantic releases. We got cache management for builds. We've got cron jobs or scheduled tasks, static code analysis, pull requests, notifications, and then there's a whole host of other things that we can do inside of GitHub Actions or that we can use. And this is a really cool repository called Awesome Actions that you can go out and take a look. There's tons of information on here of all these cool things that you can do, specifically related to maybe your programming language that you're using or your tech stack, your test suites, things like that. This is a really cool repo that you guys can go out and check out. There's tons of stuff that you can do here and tons of information. So the first example here that we're going to look at is just a scheduled job or cron job or scheduled task. And then you can see that all this is doing is literally executing a bash script or a shell script inside of our workflow. And this is running on a timer trigger. And these timer triggers use the cron syntax that we all know and love. And this is going to run at midnight UTC every single day. And then if you see below that, we've got the workflow dispatch tag. Now this tag allows you to manually trigger the action inside of the GitHub web app, and we'll kind of take a look at that later. But this can be super useful for things like database backups, automation testing, generating reports, notifications, tons of other things, cleaning data, things like that. If we want to just quickly check out the repository here, very small repository. All we've got here is one workflow, that workflow that we saw, and it just runs that specific shell script. All it's doing is echoing hello world. Um, but you can define obviously whatever you want inside of that script, and it will run that on a timer trigger. So that's something that maybe not many people know about. And it can be super helpful for some of the processes that you may have in your workflows. So the next cool thing that we can do with GitHub Actions is semantic release example, or the semantic release example, right? So this is going to use the semantic release NPM package to manage releases via commit messages. So in semantic release, there are three types of releases. We've got major, minor, and patch. And we can create releases based on a bunch of different conditionals, and maybe if you push it to your main branch, or if there's a whole host of other things that you can define conditionally to run this. But basically all that the npm package does is it scans your commit message and it will create a release based on that commit message. So if we want to go hop into this repo and kind of check out what this looks like here, maybe if you want to zoom out just a little bit.
Mhm.
Great. Okay. So you can see this is just a Next.js app. Very just basically like a hello world app. And you can see on the right, we've got two releases that have been defined all via commit message. And then one of them is obviously a major release, and then we have a patch release, right? So if we hop into the GitHub workflows, first let's look at the Docker build push. So we've got two workflows here. We've got Docker build push and we've got release, right? So all this Docker build push workflow is doing is it's running on push to the main branch. It's building the Docker image by running on Ubuntu latest GitHub hosted runner. It's checking out the code. It's setting up the Docker build X with the Docker build X action. It's logging into Docker with the Docker login action. And then if you see, we are using some credentials here that are stored inside of the secrets within GitHub Actions. And those can be easily grabbed inside of our workflows via that syntax. And then finally, it's building and pushing that image to the Docker Hub. And you can see that it's running the Docker file inside of the repo in that workflow. So pretty simple. All it's doing is pushing that. And then if we look at the release example, this workflow is only going to run once the Docker build push workflow has completed and only on the main branch. And this is going to create a new release only if the commit messages satisfy the semantic release run on the main branch, right? So if we look at the job, we've got some permissions modifications there to be able to write to GitHub, and then we've got an action that checks out the code, an action that sets up Node with a specific version. Then we're globally installing pnpm. We're creating a frozen lot file of all of our dependencies. And then we're creating a release with the npx semantic release command. And this, like I said, it's going to scan your commit messages, and it's only going to create a release if those commit messages satisfy the rules that are defined within the npm semantic release package docs. So a pretty cool example here. Kind of helps to automate things and keep everything very nice and clean. The next example that we're going to look at here is cache management. So with a lot of legacy systems and even some current systems that we see, we have very long build times, sometimes upwards of 30 to 40 minutes. And sometimes these can be drastically reduced by caching things like dependencies or installing, Node or things like that. So we're going to kind of take a look here at a cache management example. We want to hop into that repo there. Sorry to make you click around so much, but
That's what I'm here for.
yeah. All right, so as you can see, this is a super simple project. All we've got here is a README and then a package JSON file with a bunch of dependencies inside of it. Obviously, when you're using Node.js, you're going to be installing tons of things. And if you want to hop into that GitHub workflow, we've got 3 different workflows here. We've got CI no cache, CI cache, and CI cache advance. So first, the CI without cache, super simple, easy workflow that literally all it's doing is it's running when we manually dispatch it. It's running on an Ubuntu latest GitHub hosted runner, checking out the code, setting up Node with a specific version, and it's just running a yarn install, which is just installing the dependencies. The next workflow, or the CI cache workflow, very similar. Actually, it's basically the same thing, but instead of just installing the dependencies, it's also caching the dependencies. And this cache is located in, if you want to scroll up just a little bit, if you go to that Actions tab at the top, yeah, right there. And then we look at right on the left side under Management, the cache is right there. So we can see we've got our dependencies cached and then also our node setup cached. So if we look at the CI cache advanced, that's where that node cache is going to kind of come into play here. So very similar. It's caching the dependencies and then it's caching node, right? So this may not seem like a lot, but it can drastically reduce your build times. And if we go back to that Actions tab at the top, we can take a look at how long these took. So CI without cache took 1 minute and 15 seconds, and then the advanced or the basic CI cache took just under 1 minute, and the CI cache advanced only took 31 seconds. So 31 seconds versus 1 minute 15 seconds, you know, about a 44-second difference. That may not seem like a lot, but when you have a project that grows larger and larger, it makes a big difference. And obviously that cache will be invalidated on any time that your packages change, so you don't have to worry about purging that cache manually or anything. So that's a really cool example of something you can do. And then finally, we're going to dive into more of a complex example that kind of wraps everything that we've discussed here together. So there's a clean architecture starter template that I've used in the past. It's by, I believe his name is Jason Taylor. He has created this template. It's got a full CI/CD pipeline that leverages GitHub Actions. It's got templated Azure Bicep infrastructure as code files that get deployed via a PowerShell script, or the resource groups get deployed via a PowerShell script, and then the actual infrastructure gets deployed via GitHub Actions. And if we take a look at this repo here, we'll kind of just look at it to start out with. So this is a clean architecture project. If we step into the source directory, you can see that we've got 4 projects here, and this kind of goes back to that onion example where we've got the core, which is the application project, and the domain project. Now the application project has one project reference, and that is only to the domain project. And then you've got the outer layer, which is the infrastructure and the web projects, and those 2 projects will have access to the inner core of the clean architecture pattern. So it's just a really pretty organized way of setting up your .NET projects, or like I said, you can really use any programming language as it's agnostic to that. So if we want to take a look first at the scripts, we've got 3 scripts here. We've got checks, setup, and cleanup. The setup PowerShell script, all this is doing is literally setting up our Azure resource groups for 3 environments. We've got development, staging, and production. And then it's also creating some secrets to throw into our GitHub repository. And this is all automated. All you have to do is initialize and commit to a GitHub repo. Then you can run these PowerShell scripts, and it will automatically create everything for you. It removes the massive headache of having to set everything up manually, and you don't have to worry about, you know, going into the Azure portal, manually clicking through everything. You can also, you know, customize this if you don't want 3 environments. You may only need 2, or you may want 4. You can add as many as you want. You just got to modify the scripts, and then the bicep files, and then also the workflow files. So the other script that we're going to take a look at here is just the cleanup script. And what this is doing is it's removing all the resources from Azure. So if we do make a mistake or anything, we don't have to worry about it. We can just run this cleanup script and it will remove everything from Azure. All right, so next we're going to take a look at that .azure directory, and we'll take a look at the bicep file in there. So this is where our infrastructure as code lies, right? It's just a bicep file, and it's defining three environments: production, staging, and development. And then we've got a few different resources that are being deployed or being defined inside of this bicep file. We've got like a SQL server, we've got an app service plan, an app service, we've got key vault, log analytics, and all of these are being defined for all three environments that we have. Not super complex. Obviously, these can get more complex as you have a larger project. But the good thing is you can create different bicep modules. You don't have to have everything in this main.bicep file. All right, so next we're gonna finally hop into the GitHub Actions here. If you go into that .github and then inside of the workflows directory, we've got three different workflows in here. So first we'll step into the build workflow. So from the top, all this is doing is running on push to the main branch. It's ignoring some paths inside of our repo. And then we've also got a workflow call defined right here so that this template can be reused like we saw earlier in the presentation. And we've got some inputs that we can pass along with it. And then if we scroll down a little bit, we've got one job called build running on Ubuntu latest runner, checking out the code, caching the NuGet packages with actions. We are installing .NET, restoring the solution, building the solution, testing the solution, publishing the website, uploading the artifacts, and then it's also using EF Core, which is an ORM for object relational mapping for our database. It's installing .NET EF tool. It's creating our migration bundles, zipping that up, and then uploading that bundle artifact. So next, if we want to step into the CICD.yaml file, we can see that this is also running on push to the main branch, ignoring some paths. It's setting some permissions. And then it's also, it's got four jobs. It's got the build job, it's got deploy development, deploy staging, and deploy production. And you can see that it's using both the build workflow and the deploy workflow inside of the jobs there. So it's reusing those workflows so we don't have to define the entire workflow inside of each file. It just makes it much easier to read, and like I said, it's don't repeat yourself type deal here. So finally, we just want to take a look at that deploy file. This is running on workflow call, like we just saw in that CI/CD workflow. It's changing some of the permissions around. The first job that it's going to take is validating our bicep files, right? So we don't want to just immediately try to deploy our bicep, right? We want to validate it, make sure everything is correct. So this step kind of handles that. You can see that it's checking out the code. It's logging into Azure with environment variables that are defined under that specific environment name, where the name equals development. It is then using the ARM deploy, and then it's running a pre-flight validation for that main.bicep template, as you can see in the template tags there. And then it's also passing some parameters as well. Like we had seen that main.bicep file is parameterized or templated in that way. And then the final step that it's taking here is the deploy step. And you can see that it needs the validation step to complete before it runs. And then it's getting the specific environment name, and it is going through the steps that it takes to, similar to the validation, it's logging into Azure, and then it's deploying that infrastructure, and then it's also initializing the database and ultimately deploying the website to our app service. So this is just kind of like a really cool starter template that you can use for your larger enterprise applications. It's really maintainable and it's great. It's basically all batteries included already for you. So yeah, then if you want to hop back to the presentation, that's kind of the meat and potatoes here that we have for you for how you can use GitHub Actions to um, enhance your CI/CD process and kind of take those old legacy applications and modernize them with more modern solutions, right? So for next steps, we do have a free, offer a free application modernization assessment. And then we have also a free AI and Copilot envisioning session, in person or virtual, of up to 100 people. So really want to thank everyone here for attending. We hope that you've gotten something out of this, whether it be, whether you're a newbie or you've used it or you use it daily. Hopefully you've gotten something out of this, and we really appreciate your time today. So thank you very much. And then if we do have a survey for you to fill out, if you wouldn't mind, it helps us out and helps us improve. So thank you very much for your time today. Really appreciate it.